All right, let's do it. So we have about 16 minutes, which actually we are going to be able to get through quite a bit of our Unit 5 notes. It's really not an intense unit, even though there are several pages. There's a lot I'm actually going to chop up and throw away. So let's take a look and see how this goes. We start off with a recap of 098 material, which is, I feel like it's a little bit unnecessary. So I'm just going to give you little snippets, and I think it'll be enough to jog your memory of what we've done in 098. As a reminder, I do have my 098 videos. So if you are like, that snippet didn't really help, well, between now and tomorrow's class, go ahead and take a look at my 098 playlist, and you'll want to look at solving systems of equations. Okay, that's essentially where you'll want to start. Let's take a look. So we start off with a recap of our slope discussion. We start off by talking about horizontal lines and vertical lines. As a reminder, a horizontal line is always of the form y is equal to a number, and your vertical line is always of the form x is equal to a number. So when we're asked to graph y is equal to 2, well, we know that that means I need two ordered pairs where y is 2. So I can make x anything my heart desires. It literally could be anything. I could say that x is -1 or x is 0. It doesn't even matter, so long as y is 2, which means I can plot those points in -1, 2, and 0, 2. I could even go 1, 2, or 2, 2. It really doesn't even matter, okay? Once we have our points, we connect them with a straight edge. I don't have my straight edge available, so I'm just going to connect them like this, and it looks pretty straight, so I'm happy. Oh, and there it is. I found it. I use this as my straight edge. This gift card is like 2 years old. I don't know when I'll use it because cheesy Eddies, it's so much better. Anyways, okay, so we've got y is equal to 2. Our second one, x is equal to -1. Same thing. What this is telling us is that no matter what happens, x has to be -1. So that's going to go in our first position in each ordered pair. And we only need 2 points to make a line, which is why I only picked 2 points. And the other number could be anything you want. It could be a 2, and maybe it could be a 1. Like, who cares? So -1, 2. So -1, 2 is approximately here, and then -1, 1 is here, and you know, we could do -1, 0, -1, -1. It doesn't matter as long as your x coordinate remains -1. So we'll connect these with a straight edge. Excuse me. And then draw arrows. And there you have x is equal to -1. Easy, right? This is a recap. We've seen this on 098 plenty of times. Let's turn the page. Okay, well then, graphing with the slope-intercept form. When you have your function y is equal to mx plus b, right? That's the slope-intercept form. This is what we're used to from 098, slope-intercept form. Tiana, what's your y-intercept and what's your slope? My slope is?
3/2.
Yeah, perfect. And what's your y-intercept?
I'm sorry. I'm blanking right now.
That's
okay. Oh, it's a 1?
Yeah, 1. Perfect.
Sorry.
Yeah, that's right. So you're going to write it as an ordered pair. Yeah, Tiana's totally right. The y-intercept was 0, 1, right? 1. So in order to graph this, we always start at our starting point. It doesn't make sense to start at slope because that's not a point. That's not a point at all. So you start at your starting point, which is 0, 1. So 0, 1 is on the y-axis, which you knew it would be because it's a y-intercept. You then want to apply the slope. How do I apply the slope here? What does this tell me to do? Shout it out.
Count up 3, right 2.
Yeah, score. Up 3 over 2. So, and it's always to the right, which is actually really important. So I'm glad you said that, Shane. It's always to the right. So you're going to move up 3 units, 1, 2, 3, and over 2, 1, 2. That's all we really need. I could plot another point. So 1, 2, 3 over 2. And now I'm going to take my straight edge, connect the dots, and I have my line. It's funny. It kind of seems like we spent 2 or 3 weeks just learning how to do all this graphing. And now it's like, oh yeah, that's right. That's all I have to do. For part B, negative 2x minus 3y equals 6, it's not in the right form. We could do this by finding the x and y intercept first, and then by calculating the slope based on the graph. So I actually want to do that with you first. If we want the y-intercept, we know that x has to be 0. So I'm going to start by calculating the y-intercept, knowing that x is 0. So we have negative 2 times 0 minus 3y is equal to 6. Notice that this gives me a 0, so I have negative 3y is equal to 6. And then, of course, if I divide by negative 3, I get that y is equal to negative 2. So just like that, I found my y-intercept, 0, negative 2. But I also want to find the x-intercept because I'm going to use those points to help me find the slope. This is a strategy we learned in 098, that sometimes it's helpful to find the intercepts before you find the slope. You don't always have to rely on slope-intercept form. So this time I'm going to plug in a 0 for y. So I have negative 2x minus 3 times 0 is equal to 6. Hopefully you're all remembering this, like how we find the x and the y intercepts. This term goes away, leaves me with negative 2x is equal to 6, right? That goes away. And then we divide by negative 2. And we find that x is equal to negative 3. So I can actually note here that my x-intercept is negative 3, 0. So why don't I plot the 2 points and see what this looks like? So negative 3, 0 is on the x-axis. That's how you know it's an x-intercept. And then 0, negative 2, that's on the y-axis. So there's our y-intercept. I'm going to connect these 2 dots with a line. I use my straight edge so that it's perfect. And now, if I want to calculate slope, remember that all we have to do is count. How do I go from my first point to my second point? What do I do?
Down to right 3.
Perfect. You just said it. Down 2, right 3. Okay, so my slope is down 2, right 3. We had to fall 2 units, then we had to run 3 units to get to the next point. So fall 2, run 3. Check it out. If I'm at my second point and I fall 2 units and run 3, I just found another point on the line. Pretty cool, right? Fall 2 units, run 3. I just found another point on the line. If I go backwards, 3 units backwards, 2 units up, I found yet another point on my line. So anytime you move from one point to the next, you recognize that the slope is the same, down 2 over 3. So it's another technique that you should be familiar with. It's finding the intercepts first and then using the graph to calculate the slope. Perfect. Again, this is a recap. I have videos that cover all of this. Don't hesitate to look at those if you'd like a refresher. When we solve systems of equations, we in 098 only looked at 2x2s, right? X, Y, X, Y. We didn't look at anything bigger than that. So as a refresher, when 2 lines intersected, that meant that you had one solution, right? And that solution happened to be the ordered pair XY. It was a point on both of those lines. It was the point of intersection. So it was right there. Our point of intersection was our solution. When our lines were parallel, meaning they never, ever, ever will cross, that meant we had 0 solutions. We didn't have one. So we would write no solution. We know that lines are parallel when their slopes are the same. And then lastly, when we graphed and we found that the lines were exactly on top of each other, there would be an infinite number of solutions. And we would actually write that because it's essentially the same line. So there's an infinite number of solutions. We would know this because the equations were the same. The equations were literally identical. Maybe not at first, but once you wrote them as slope-intercept form, they would be identical. So a system that had a solution was consistent. A system that did not have a solution was inconsistent. And then a system that had an infinite number of solutions was dependent, right? So let me show you this one super quick. Let's start by graphing y is equal to x plus 2. For this first one, would somebody tell me what's your slope and what's your y-intercept? Your slope is?
Is it 1?
Yep, positive 1, perfect. And we could write that as 1 over 1 if you'd like. Remember, y equals mx plus b. Your m is your slope, and in this case, m is 1. Good. What's your y-intercept?
0, 2.
Yeah, 0, 2. Very nice. Let's start by graphing this one. So 0, 2 is our y-intercept. We're going to start here. And then we're going to apply the slope. Positive 1, that means up 1 over 1, up 1 over 1, up 1 over 1. So we're going to plot just a few of those points. And then use your straight edge to connect the dots. Cool. There we have it. So this is the equation y is equal to x plus 2. We're going to do the same thing with y is equal to 2x plus 1. So someone else, what's my slope? So someone other than Tiana and Shane, what's my slope and what's my y-intercept?
Slope is 2.
Yes, beautiful. Your slope is 2 because it's a whole number. We can write it over 1. So 2 over 1. Excellent. Someone else, what's my y-intercept?
1.
Yeah.
1.
0, 1. Perfect. 1 or 0, 1. So let's plot our y-intercept, which is 0, 1. And then we're going to apply the slope. The slope says up 2 over 1. So up 2 over 1. What do you notice? Up 2 over 1. Let's connect with our straight edge. We're seeing right away that our solution is here. So the solution is the ordered pair 1, 3. The two lines are intersecting. And if we ever wanted to actually check, we would take the original equations and we would simply plug in 1 for x and 3 for y. We would plug in our values. So y is 3, x is 1. Oh, 3 equals 3. Cool, that checks. But you have to check both equations. It's not enough just to check one of them. Y is 3, x is 1. So we have 2 plus 1, and that's also, it also checks. Perfect. So we did this correctly. Beautiful. This is a quick reminder of what we did in our, excuse me, in our, gosh, in our last class. So we can solve systems graphically. We tended not to do that. That was only our first method. We tended to use substitution or elimination. So I'm going to go ahead and turn the page. Okay, and actually I'm not going to worry about B or C because this is again just a refresher of, hey, can you graph these lines? And then once you have them graphed, do they cross, right? Are they parallel? Are they the same line, et cetera, et cetera? Don't worry about those. Let's move into solving systems by substitution. So this was our second method. We could graph our systems always, but sometimes we were very limited, right? In the sense that we can't always graph it by hand. It's a little complex. So what we can use is a method called substitution. So let me remind you what substitution looked like. So notice on my first system, I have y is equal to 2x plus 4. And then my second equation is y plus 4x is equal to 2. Well, we are going to use substitution in this case because they are telling us that y is 2x plus 4. So remember from last time, I recall from 098, that if I know that y is the expression 2x plus 4, I'm going to sub that into my second equation to replace y. We're going to substitute. So that means I have 2x plus 4 plus 4x is equal to 2. Once I sub in, I'm going to combine like terms. So I get 6x plus 4 is equal to 2. I'm going to subtract 4. 6x is equal to -2. Divide by 6. And we find that x is equal to -1/3. What we also learned is that there are two unknowns, x and y. We cannot just solve for x and say, okay, cool, I'm done. Like, no, it doesn't work that way. We need to sub back in to find our other value, our y. And it doesn't matter which equation we plug this back into. So I'm going to plug this back into the first one. So I know that y is equal to 2x plus 4. So I'm going to take the x is equal to -1/3. And I'm going to sub it into my equation and solve for y. So y is equal to 2 times -1/3 plus 4. You know how to multiply fractions. It's just numerator times numerator over denominator times denominator. So that's just a -2/3 plus 4. You don't even have to worry about anything. Just -2/3 plus 4. Plug that in. That gives you 3 1/3, which will change to 10/3. And we just found our solution. So y is equal to 10/3. Recall that you must write your solution as an ordered pair. So in this case, our solution is a -1/3, comma 10/3. And there you have it. I'm going to pause here. I urge you, if you do not remember this stuff from 098, please watch my videos on solving systems of equations using substitution, elimination, using graphing. Take your time to make sure that that is understood, because we are moving right into 3x3 systems. If you turn the page, you'll see that they're right there. So if you look at, let's turn a couple pages, we got to do elimination. If you turn to page 8, you'll see your first system in 3 variables. Okay, that's where we're headed. And I look forward to doing that with you tomorrow. All right, everyone, enjoy the rest of your day. Make sure you're getting all that homework done. See you mañana.
Sounds
I have a
good.
couple questions.
Yeah, sure. Let me pause. Let me stop this video.